Good morning, everyone. I warmly welcome you to our first Tech Talk 2023, AIEI x NVIDIA. You are with me, Parinya Kuntuam, or you can call me Jide. I am a moderator of today's talk. Let me tell you about a little bit about our series of this Tech Talk. This talk will provide you with a special opportunity to get knowledge from international professionals who give you a functional language you need for real life and hands-on tasks in the technical, industrial, and scientific fields. Right now, we are delighted to introduce you to our first TikTok series of 2023 on the topic of creating digital twins and simulations collaboratively with Omniverse AI or for Metaverse. Our today's speaker is a Chief Technologist Director at the NVIDIA Asia Pacific South region, works with NVIDIA technology adopting researchers, innovators, startups, and techno entrepreneurs to accelerate AI and DPU inclusion for their industrial R&D and software development needs. He has published numerous publications and patents and developed software libraries in the past. He holds a PhD in computer science with a research focus on distributed computing and algorithm optimization. Everyone, please welcome Dr. Ettikan Kandasamy Karuppiah.
Thank you very much to the chairwoman who will actually to introduce the session. I will start straight away with the session. Just to be sure that the slides is coming through and it's in the presentation mode as I'm sharing. Is it clear?
Yes.
Okay, thank you very much. Very good morning to everybody. And it is not too late, 17 days into 2023. Happy New Year, everybody. Right. The talk today is about creating a digital twins, right, and simulations. So digital twin is just different than the simulation. I'm going to cover a little bit of these two topics. And the third component is collaboratively. How can we work together to create a digital twin and also simulation using Omniverse AI as a platform that NVIDIA has developed. It's an open platform. Anybody can take it and use it for Metaverse. I underlined the word called Metaverse, right? So I'm going to explain a little bit of what is exactly Metaverse and why Omniverse AI platform is important to help build the Metaverse. Then we are not going to do alone. We have to work together with everybody in the world because it is a collective effort to have this Metaverse to be created. As I explain Metaverse, I'll tell you why the collective effort is very important. And through digital activity that happens in the process of building Metaverse is creating a digital twin and some of the simulation activity, beside many other software development activities, engineering activities that will happen throughout the process of building Metaverse. Now, I'll start with, there was a research done by researchers in Europe. They wanted to ask people, especially the technologists and especially the technical people, right? They asked, how will Metaverse will evolve by 2040, right? So the question was, based on whatever they understood, whatever you understood about Metaverse, right? Which state comes closer to their view about what likely the evolution will be by 2040. As you know, not many people are aware what is Metaverse, right? So almost 50% of them responded, Metaverse will be much more refined, truly immersive, fully functional, and can be adapted very well. And the other almost, close to 50%, they were not really sure. They were reluctant to explain and able to share what do they think. And they think it may not have an impact to the world, right? So if you can see there, it's almost, but the 54%, I would say it's about 50%, right? 54%, of course, they said it will become a fully immersive. And the other 46% were not really sure. So this is just a quick response where the research actually intended to find out how does ordinary developers and researchers actually find Metaverse. Now, I have not explained what is Metaverse. I'll do that later. Okay, but if you, this is a few hundred page of a research report. So those who are interested, you can go to the report at the bottom down there. You take a look at and read, right? Now, what is metaverse, all right? So internet that we are using today, if you can say, pandemic has disrupted the way that we work, the way that we learn, the way that we communicate. But this fundamental communication that's taking place is due to the strength of internet that we have built for almost 30 plus years, right? Since 1980s, when Ethernet was invented in one of the labs, right, AT&T lab. Today we have the entire internet has been running everywhere globally, from mobile device to PCs, laptops, IoT devices, and so forth. But is a 30 years old journey, right? So those who are studying on IT, or you are studying on computer science or computer engineering, briefly, you will know in 1990s, that's where the World Wide Web was invented, right? And then progressively, many other technology has been invented, right? With this, you can see it's just a simple journey. The progression from internet or IP protocol, right? Those who are familiar with IP protocol, invented, slowly has progressed. Today, in 2021, Meta, which those, I'm sure you're familiar with the company called Facebook, right? Which is announced the name of the company to become Meta. So the concept of Meta actually came from metaverse, right? How to build the metaverse. So what does it mean? We have internet, which is 30 years old. We need something new infrastructure after this. So the industry actually looking at building what we call as a metaverse. Now, the definition of metaverse varies from people to people, right? There is a lot of research papers that I would suggest for you to take a look at it and understand what do they think what is metaverse is. So this is one of the paper that I'm sharing with you. It's bounded by infrastructure, internet connectivity, high speed, high bandwidth, high bandwidth, low latency type of infrastructure is very important. Human interface, it is a decentralized, it has a spatial computing, it will become the new economy generating activities as we build the metaverse, right? There's a discovery and experience process. So there is a 7 layers of metaverse platform, which we will build on in the next 10 to 20 years, all right? Now, from NVIDIA perspective, we are very much aligned. In fact, we're already building the foundation for the metaverse with the platform called Omniverse. And for example, we are closely working with many companies, including Meta, who's building the components of platform for this metaverse. And we understand AI is very, very foundational for this metaverse. Let me explain to you why it is important. Now, so we briefly, I would say, metaverse is actually the 3D evolution of the internet. So today, internet is very much 2D, right? There is no 3D component. I'm sure those who are familiar with virtual reality, mixed reality, right? Or XR we call, right? All kind of virtual reality, mixed reality, and all that comes as we call XR, which is a different type of a reality which comes in, right? It is extension to that, but it's more than that, right? So for example, if you can see over here, there will be a lot of digital assets being created. Digital asset could be not only an avatar that if you can see over here, there's a small avatar over here. The jacket for the avatar, the shirt for the avatar, the blouse for the avatar, all that will be created as a digital assets, right? So this is a collection. There's one area, a very big area, right? The next is converting all the 2D into 3D. So today, I'm sure if you can, there is many applications available. You take your iPad or any device with the camera built in, any handheld tablets or a mobile phone, the camera. Today, a very good camera which can do depth understanding or depth estimation can eventually convert actually a 2D image to become a 3D, right? With a bit of a software intervention. So a lot of content will become interactive. It has a 3D element to that. The next, if you can see, is what I call is we look at every industry will participate in the metaverse process. One of the participation is through digital twin, right? So they want to visualize the environment. For example, in this case, it could be warehousing. In this case, it could be, it could be a campus where that you are studying, right? So you can create a 3D environment of the campus. You can actually do some kind of a visualization, and virtually you can attend a campus lecture rather than you physically coming to a lecture hall. You can sit at home. You can use, for example, VR glass at home, and then virtually you present. Virtually you can talk to your friends, right? So the digital twin of the campus will allow such kind of interactivity. Next is in terms of understanding physics particles properties in, for example, factory environment, right? The next we look at in terms of telecommunication sector, right? Visualizing something which is not visualizable. For example, how do you understand X-ray rays, right? How do you understand the wireless signals, strength, and so forth? So all these could be visualized in the terms of what we call as a digital twin, so that we able to understand the digital twin, and we can actually use it to interact and plan. And so goes many other use cases, right? From factory environment for autonomous driving, including creating a digital twin of the world so that we could understand the world. We could, try to study the climate change impact by creating a digital twin of the world and putting all the data together. So it's, in a nutshell, the evolution of the internet to be a 3D internet, it is what metaverse. But as I say, it is a progressive work. A lot of research work taking place. Many of the companies are putting a lot of engineering effort, and they are building it gradually, right? And how does NVIDIA help to build these virtual worlds, right? So we ensure we take an open standard. A few points just to stress here. Metaverse, same like internet, doesn't belong to one person, doesn't belong to one country, doesn't belong to any companies. It is globally owned by everybody. It's a shared platform, okay? And in order to build this platform, everybody has to work together. Same like internet, right? Everybody has to put the information in the internet. Then only you can search and find the information. If nobody puts the information, nothing much you can search, or you can, you don't have video to watch. So somebody must be contributing. In this case, everybody is going to contribute. That's one, open standard. Next is simulation technology. So we find a lot of simulation technology is critical to build the 3D world. Why? The 3D world has to represent as much as possible close to the physical world, right? So we need to bring the physics property of the real world into the virtual world so that we can interact, we can work with the virtual world to solve some of the problems that we have in a 3D space, in the virtual world rather than physical world. So bringing material information, behavioral information, physics information, right, into the simulation technology in order to create a virtual world is essential. And fundamentally, in order to build this virtual world, we see AI plays a critical role. I'll tell you how AI actually plays a critical role with some good examples. And as you know, today, all of us are using a cloud, right? All of us using compute without even we see where the compute is located. If you have a laptop or if you have a PC in front of you, you can see there is a laptop, there is a PC, there is a processor, there is a keyboard, and there is a whole infrastructure. But a lot of work today being done by just using mobile phone or even some of the IoT devices that we have, you don't even see the interface to that. Why? Because the compute exists somewhere, right? May not be even in Thailand, maybe somewhere in a different part of the world, but the compute infrastructure able to compute and able to deduce and give you the results, right, in a very simple GUI interpretable way, right? So in order to achieve that, we believe a computational infrastructure is very important, including a specialized hardware. That's where NVIDIA is spending billions of dollars researching, developing our products to build this metaverse. Now, as we speak, I always get a question. Is this metaverse is our imaginary thing? Is it really real? For information, it's already here. We are already, NVIDIA as a leading company in the world, we're already working with many companies, right? Both in globally, regionally, even locally in Thailand, right? There are many companies looking at 3D designs of goods and content and environment. For example, the content creation industry is growing in Thailand. So they use a lot of NVIDIA tools, Omniverse platform for their content creation. Next, in terms of building digital twin, right? For industry standards, we see there is a lot of companies in Thailand already building their own digital twins, right? For industrial use cases, for scientific use cases, for even for entertainment and so forth, right? Next, if we're looking at it in terms of robotics, autonomous vehicle, there are companies in Thailand already actually building a digital twin for robots to be trained virtually before the robot being deployed. So, I personally working with some of the leading companies in Thailand who are already doing this autonomous vehicle. There is one company there which does not only EV, but EV with cameras with a perception capability. For example, building a tut-tut, which has a little bit of AV capability, right? It's already happening. Avatars and also AI for teleoperations, right? That is, all these are already happening as we speak, not only globally, even in Thailand, right? So that's important as a student. You're prepared as you go to the industry, start working. You have the fundamental buildings, fundamental skills to start projects and research work in this particular space. Now, briefly, I won't go into detail of the architecture or the software component and elements. I'll give you a pointer end of the slides. You can download and play with Omniverse, right? But the way that we're building it is, we can see over here at the bottom, it runs on extremely fast and well on NVIDIA GPUs. It has a many framework which allow you to build on top of that, right? Complying to the standards. AI is one of the key components. We will go through some examples of AI-enabled frameworks library that will be useful. So if you're taking an AI class, you're a year 1, year 2 students, you get introduced to AI. Now you will see AI in a real world, AI in industry, how it is being applied to solve a problem, right? In this case, we want to build a digital twin. And then if you can see over here in terms of simulation, how it's being rendered, right? And then all this is made possible by creating a application, kit extensions applications, right? And this must be run on a cloud native mode, running on multiple GPUs and CPUs and GPUs, right? Using standards that everybody can collaboratively work, which is using USD, Universal Scene Descriptor. I'll share with you how we're adapting this, right? Okay, so this is how NVIDIA is building, okay? I won't go into detail, as I shared with you. You can download and explore. Let me go through and share with you, what does this collaborative means? How can we work together to design a digital twin environment? Let me share with you one quick demo. If you can see 3 different persons sitting in a 3 different part of the world, doing 3 different design work. This is a person A, person B, person C will be doing 3 different work, but you can visualize this on your right-hand side as a single view of a 3D environment, how the activity is taking place, right? So let me play the video clip. So if you can say here, don't worry, there's no sound to it, right? I disabled the sound for a while. If you can see here, somebody is designing one component over here, and that appears. And somebody is painting, the paint appears in this. And then over here, somebody is designing the desk for the kitchen, right? And then the desk appears here. So as he changes the component, the activities over here. So that's how three different persons can collaboratively design certain things, and then you put together and make sure it happens over here, right? So this just to illustrate how an example of 3D in a 3D environment, collaboratively, three people can design. But it's just a simple example. You'll go through more complex example how this can be done. Okay. Okay, let's move to the next slide. Right. Okay, so before I get into detail, a little bit of what exactly collaborative design or design collaboration means, all right? So designers, can be a kitchen design designed by a few engineers putting together, more for a building-like environment. But remember, there's just one small example. The designer can be used for clothes designing, designing architecture of buildings. It could be even for design of content in a movie, right? A lot of your digital movies, which is designed by many people. So all these are all called designers who are actually designing. So this could be a creative industry. You could be a creative designer, right? So they actually work together, and they work together. They work with the project leads, who is a person leads the project. Now, the project leaders will, as a company that you also work with your clients, right? So designers is you have a project leader, you have the clients, right? All of you can actually work together to design something meaningful in a short period of time. So this is where the collaborative design comes in, right? So the intent of Omniverse is to allow you to create, view simultaneously, and then improve, give ideas, give suggestions so that people can accept the idea for implementation, right? For building and so forth. So that is a quick concept, how in the spaces, whether in the fashion industry, architecture industry, engineering industry, operation industry, construction industry, all of them can use this collaborative design. Now, let me give you an example how, as I shared, collaboratively people can work even to make a movie, right? And interactivity comes in, right? So let me share this example. There is an audio to this. There's a sound. You will hear the sound. So in this example, a movie industry, how are they using Omniverse to take a movie using 3D in a virtual environment?
WPP is the largest marketing services organization on the planet, and because of that, we're also one of the largest production companies in the world. That is a major carbon hotspot for us. We've partnered with NVIDIA to capture locations virtually and bring them to life in studios with Omniverse. Over 10 billion points are turned into a giant mesh in Omniverse. For the first time, we can shoot locations virtually that are as real as the actual places themselves. Omniverse also changes the way we make work. A collaborative platform that means multiple artists at multiple points in the pipeline in multiple parts of the world can collaborate on a single scene. Real-time CGI and sustainable studios, collaboration with Omniverse is the future of film at WPP.
Yeah, so you look at it, in the film industry, right? In the movie industry, or making short videos or advertisement and so forth. They don't need to go to the real place to go and take the shot. Somebody could actually take a scene A, scene B, scene 3, and these 3 scenes can be brought into the studios. you can play it, and you can record on top of that, and you can create a scene, right? So that's how the collaborative design, right, in the case of movie industry, is actually using this in order to create their content. It's just one example, right? There's many examples. Okay, next, if you see, I'll just show you another example. Okay, so before I get in and show you another example, I want you to understand what is the effort required to build a digital twin, right? Digital twin of a campus, digital twin of a bicycle, digital twin of a building, digital twin of a city, right? All these that exist physically, you can build a digital twin. So one of the key features is to have a full fidelity visualization. So the visualization must be very real. It's as though you see a real bicycle, you see a real campus, as you see a real building. It must be very real, full fidelity. The material, the lighting, the visualization, the reflection, the shadow, the change of a shadow over a period of time as the sun moves, all this is a fidelity, right? And in order to create this, you need a good custom tools, right? The tools is very important. And the physics properties is also crucial. Like, for example, as the sun moves, the shadow actually should be keep moving based on the direction of the sun, right? So the light comes in, there is an object actually obstructs the penetration of the light, creates a shadow, and the density of the shadow changes because the density of the sunlight changes over a period of time. So all that is the physics properties, and that has to be shown. Now, we also see, as part of the digital twin, the sensor inputs are very important. So sensor input could be camera, could be LiDAR, could be radar, right? So all these are the sensors which creates the data sets, which is extracted from the real world, right? And of course, including others, for example, audio and so forth. Next, as we put all this together, we want to make sure that all these components, all the tools, all the sensors should work cohesively, coherently, right? Autonomously as much as possible, so that the digital twin, it becomes as real as possible. Right? So that is the challenge as engineers, as researchers, as a scientist, building the tools and components for the digital twin. And again, digital twin is one example of metaverse. Okay, let's look at the next example of digital twin that we created in NVIDIA together with our partners for data
NVIDIA
center.
Omniverse.
So if you know data center is a place where all the GPUs, all the CPUs are put together, like in a cloud, right? There is a big compute infrastructure where all the servers are being located. Hundreds of the servers, thousands of servers, 10,000s of servers, right? It's a data center. And how you can use digital twin from the design stage all the way to operationalization. Let's look at this.
Omniverse can be used to build digital twins of high-performance data centers to help optimize every step of planning, building, and operating complex supercomputing facilities. In constructing NVIDIA's latest AI supercomputer, engineering CAD datasets from tools like SketchUp, PTC Creo, and Autodesk Revit are aggregated so designers and engineers view and iterate on the full fidelity USD-based model together. With Patch Manager connected to Omniverse, the complex topology of port-to-port connections, rack and node layout, and cabling can be integrated directly into the live model. Next, CFD engineers use Cadence Six Sigma DCX to simulate thermal designs. Engineers can leverage AI surrogates trained with NVIDIA Modulus for real-time what-if analysis. And with NVIDIA Air, a network simulation platform connected to Omniverse, the exact network topology, including protocols, monitoring, and automation, can be simulated and pre-validated. Once construction is complete, the physical data center can be connected to the digital twin via IoT sensors, enabling real-time monitoring of operations. With the perfectly synchronized digital twin, the engineers can not only simulate common dangers, such as power peaking or cooling system failures, but also validate software and component upgrades for CI/CD before deploying to the physical data center. With digital twins and Omniverse, data center designers, builders, and operators can streamline facility design, accelerate time to build and deployment, and optimize ongoing operations and efficiency.
Great. I hope you enjoyed the video clip, which shows the data center all the way from design into deployment and operationalization. So imagine if I can build a digital twin of this data center, I'm sure I can build a digital twin of your campus. And if I can build your digital twin of your campus, if you're using whatever the AR, VR headset, HMD we call head mount device, you can virtually go, you can walk around your campus, you can talk to your friends in campus virtually, right? So that's where it's a concept of metaverse, right? Remember. So next is I'm bringing you to a digital twin of a factory, right? Data center is one example. Next example is factory, right? This is what has been built by BMW. Let's take a look at their digital twin. All right, so over here, if you can see, the whole manufacturing floor is built in digital twin. Whatever you are seeing today in this video, it is not real. It is virtual. That means it's all designed. So if you look at it, it looks almost real, right? Almost real, or it looks real. Okay. Now this allows companies to understand the workflow of a work. They understand how a factory automation should be designed. They want to look at safety and security. And all this can be done as a collection of work that they're already doing today. Like they're using Autodesk, Maya. It's all the tools that we have today can be put together. So for example, this is visualization of an engine. Engine has more than probably thousands of parts, and how those thousands of parts are put together without any defect so that a proper engine can be designed. But it's not only engine, but also there are so many components in the factory, right? How all this can be put together. So by having a digital twin, the researchers, the planners, those who are familiar, a word called operational research, OR, right? It's very important. In many companies, almost 20 to 30% of the staff is actually to do planning, designing before operationalization takes place. So Omniverse helps them to do this. Okay, that's a factory, right? Next, take a look at in terms of warehouse, how today companies are already using it. Before this, I shared about BMW. Next, I'm going to share with you how AWS warehouse. AWS is Amazon, right? So Amazon, where you can buy things online, they deliver to you. It is another company example how they're using a digital twin to ensure operation efficiency, workflow check. Let's look at this. All right. So this is a physical warehouse today, which is yellow color. The blue color that you are seeing here is virtual, right? So the robots can be virtually designed. The operationalization of the robots are virtual. The factory floor can be designed. If you see, he's designing it by using computer, and then he bring it into reality, right? So virtually the environment is designed. They can understand how the space can be fulfilled, and then they can even understand how the structure should be built, right? So this is where in architecture and building. So bringing architecture and building as a whole concept, you get into the warehouse. You can even next is study how the robots are operating, right? What's the best way to use the space utilization? What should be put into where, right? And the whole automation of the warehouse can be simulated, understood, and studied, right? So this is a physical part which is actually taking place in Amazon, right? And that it's kind of integrated together with the virtual, so that you can understand the digital twin operation. For example, in this case, the arm, the robot arm, right? So if you can see, this is virtual on your left-hand side. On your right-hand side is a real, right? So the intent is to understand how virtually an environment will operate and how does physical environment operate, so that you can bring them together for implementation, right? In this case, in order to pick and place an object, right, can be simulated, and then you can train the robot to do a pick and place of arm to do properly for the object. So in this case, this is a big object, this is a small object. The robot needs to know big object might be heavy. I got to use more strength to pick up the object. This object is small, I need less strength. Okay, so this is where the AI comes in to do object identification, segmentation, classification. Then the strength required is based on the weight of the object. Right? So all this AI comes into play. That's another example, right? So next example is in the case of, this is a power generation plant, right? So this is where the physics properties comes in. So when we do a digital twin, your physics formulas to be translated into a code which actually runs, and the execution of the code, of the physics code, must be able to be visualized. For example, water is boiling. The physics property, temperature has to be seen. The what do you call the gas, which is once it becomes hot, the water becomes a gas, right? From liquid, it becomes gas. The gas goes up, okay? So when the gas goes up, you need to visualize the gas going up, right? The hot air doesn't go down, it has to go up. How do you physically demonstrate that the physics properties? Okay, this is just an example, but this is what is being done in the digital twin of a water boiler, for example, in this case.
This massive heat recovery steam generator uses hot gas exhaust to convert water in the pipes into steam for the turbines. Predicting corrosion to avoid downtime is challenging. Reduced order models aren't extremely accurate, and full simulation takes expertise and time. Siemens Energy is developing a digital twin with NVIDIA Modulus for the multi-phase turbulent flow. With point cloud data to train a physics-based AI model, they can infer high-fidelity flow shown by the streamlines in seconds. This could reduce downtime by 70%, saving the industry $1.7 billion a year.
Okay, that's another example, right? How digital twin in a water boiler, for example, right? So next is, I'll share with you a quick one in the telecommunication space, right? How they are using the physics properties to plan the 5G tower, right? So before they place the 5G tower, they need to understand where is the right place to put the tower, so that the tower which sends a signal, right? It's a signal sent to your mobile phone. How strong is the signal? It depends on how freely the signal can travel to your mobile phone, right? And vice versa, without any obstruction. So how they study the physics particles and properties, all right? Okay. Is another example, a quick video.
In Omniverse, Ericsson builds city-scale models that are physically accurate down to the materials of the buildings, vegetation, and foliage. Then, wireless network components are added, including the precise location, height, and antenna pattern of each transmitter. Ericsson built a custom Omniverse extension, enabling them to integrate radio propagation data and leverage Omniverse's RTX accelerated ray tracing to quickly visualize and calculate the quality of the signal at every point in the city. Because Omniverse materials are physically accurate, the intensity of reflections are precisely determined. Antenna beamforming and signal paths can be accurately simulated and visualized. In the simulations, the lobes signify transmitter antenna beamforming and the straight lines are signal paths. The colors of the signal paths denote strength in decibels and data throughput. From blue is the weakest to red is the strongest. Visualization is a critical capability for Ericsson. With Omniverse VR, network engineers can virtually explore any part of the model, teleporting to any location, anywhere in the world, at 1-to-1 scale. As they tune the network for optimal performance or identify path disruptions, they can literally see the effects of their adjustments in real time, things which aren't visible in real life. In Omniverse, Ericsson can perform true-to-reality remote simulation of entire 5G networks, enabling them to design more efficient and reliable networks, conduct remote field trials, and speed up deployments.
Yeah, so that's another example of how it's being used in a different industry, right? Just a quick paper. I know you guys, spent year 1 and year 2, but for those who are, who are a little explorative to go and look at it, there's one example of paper that you can look at where 6G is being enabled and deployed in order to prepare for Edge AI and Metaverse. So some countries, for example, in China, right? So they actually have a trial stage of 6G being deployed. So that shows you can have 5G, you have about 10 to 20 gigabits per second of your bandwidth, but in a 6G, you'll be getting about 100 gigabits per second of peak transmission of bandwidth. So when you have such a huge bandwidth, it's a lot of use cases are possible. So that's where people are building in the next 5 to 10 years, I would say, but incremental. And another survey, you can actually take a look at this paper. They look at what are the core components of Metaverse, and AI is one of it. And what are the AI component in the Metaverse, right? It could be in terms of language modeling, right? We call LM or NLP for short. Natural language processing is one component. So this was studying AI. If you're doing NLP, put a bit more focus on this, because this is very important for Metaverse, right? The future of the internet is going to be. Those who are doing AI, image processing, computer vision, object detection, segmentation, classifications, and all that is another component of your Metaverse, right? Virtual reality, augmented reality, mixed reality, we call it XR, is another component. How do you collect data? How do you manage the data? How do you sign the data? Blockchain technology is very important. The networking or the infrastructure I've shared earlier, data-driven modeling, which is a digital twin, is very important. The next is they also look at neural interface, right? A very minute way of extracting information and exchanging information as a neural compute is going to be important in Metaverse as well. So a lot of things are coming along the way as we look at it, right? Even there is a paper talks about, for those who know AI, object detection, scene detection, how do you do AI in Metaverse, right? AI in the 3D world, AI in the virtual world. That's a very interesting paper on this to read, right? And there's many. I will skip this. Go through the papers. You will understand how they are building the Metaverse, or they are planning architecture. A full research is already taking place in Metaverse. Now, another important component of Metaverse, right, a digital twin, is having a digital twin of a human, which is called the avatar. Right? The avatar should have a vision capability. It should be able to talk to people with the context awareness. Context means how the content and how do we actually communicate. You should be able to plan and do actions like a human being. You should be able to do some gestures, body animation, face animation, emotion. All these are important. Digital twin of a human being, as we call as avatar. Let's see a good example of how this avatar could actually work in a short demo. And here, this is the CEO of Jensen talking to his own digital twin of avatar.
Let me welcome back Toy Jensen, an application we built with Omniverse Avatar. Remember, Toy Jensen is not recorded. He's completely real-time. making eye contact, making conversation, and fully animated. Hey, TJ, I got a few questions for you.
Sure, ask me anything.
What is synthetic biology?
Synthetic biology is about designing biological systems at multiple levels, from individual molecules up to whole cells and even multicellular assemblies like tissues and organs to perform specific functions. It is also known as symbio, which stands for synthetic life.
Can you give me some examples?
Some current uses of synthetic biology involve creating biofuels, engineering bacteria with useful properties not found in naturally occurring organisms, developing biosensors capable of detecting environmental toxins, producing biopharmaceuticals, and manufacturing chemicals via fermentation.
So this is an example of human digital, right? Physical Jensen talking to digital Jensen, and digital Jensen is an avatar, and he is able to interact. This is another example of a digital twin, but this digital twin will be important in the metaverse space, so that we can all have our own digital twin and talking to other digital twins, right? It's same like the Avatar movie that you watched. It's a similar. Okay.
Let me walk.
Now, a lot of fundamental work, AI work goes in order to build. Some example of papers, those who are interested to look at, is called a neural instance graphics. So it's a model that NVIDIA built, and we made it available. The intent of this model or this tool is, how can we convert 2D to 3D? See, imagine we took 30 years to build the internet. In metaverse, we want to do this much faster. One. Second is, we also want to make it into a 3D, which is graphics. Next, we want to bring in the physics properties and reality. So it's not an easy task. We want to do much faster, but we are solving a very complex problem. So new innovation, new tools, new method, new techniques, new algorithm has to be created, right? So see, for example, what we have done, I'm going to show you a demonstration. NVIDIA, who actually one of the leader in autonomous vehicle technology provider, taken this digital twin concept in autonomous driving. We have built an algorithm to convert a 2D into a 3D and put it into a simulation environment, and collaboratively can change and reauthor the whole workflow. Right? So in industrial use case of a digital twin in autonomous vehicle using neural graphics is one of the algorithms, right? Then we have developed the papers. I'll share the slide after this. Go and look for the paper, read for those who are curious to know. You understand. Let's see the demo here.
With a neural reconstruction engine to enhance simulation with AI and data captured by the fleet. In a matter of minutes, the neural reconstruction engine can reconstruct a full 3D digital twin of a recorded drive from sensor data. Objects are harvested and reconstructed using AI. Large-scale asset and scene libraries are created from real-world drives. The reconstructed scenes and assets are loaded into Omniverse and are ready to use in DriveSim. Using NVIDIA Drive Map, we can place dynamic objects, such as vehicles, as well as pedestrians. Recorded data can now be turned into fully reactive and modifiable simulation environments for closed-loop testing. New scenarios can be authored using synthetic and harvested scenes and assets. We can generate synthetic ground truth data to train perception networks. These authored scenarios can be used for end-to-end testing, including challenging scenarios. NVIDIA DriveSim, powered by Omniverse and AI.
Yeah, it's another example in automotive industry, right? Autonomous vehicle industry. So let's come back a few more details for you to understand. So the way that in order to build the metaverse is using Omniverse as a platform, right? In the university, it is free for you to download and try and develop on your own. You can work with your professor or the lecturers over there, get these tools downloaded. If you have a gaming card at home in your PC, besides playing game, you can actually download and experiment Omniverse. It's free for you to download and develop and experiment it, right? So it has a multiple component. The nucleus is a core component which allows all the rendering scene to be executed. Connect is actually connector, which connects using USD, Universal Scene Descriptor, but also following many other protocols or standards to connect to the rendering engine to bring the 3D scene, so that either you are doing some modification or you're doing collaborative design, workflow to be put together by using the connector. Two different applications can work together. Kit is nothing but then simple applications that you can actually take from the example that NVIDIA has created. Again, it's open. You can create your own and modify, create your own 3D design application as well. And then you can even do a simulation. You can simulate means that you can create a whole workflow pipeline. Sensors are interacting to create a scene. And finally, how do you render? After you get everything, you want to render. You want to make the whole scene running in a cohesive, coherent environment by using a RTX rendering application. So all this can be done, right? So USD allows layered information to be processed and to be displayed, right? Because as human being, our eyes can perceive many information together. But when we design and we develop layer by layer of objects, and these layers can be put together to make a scene of a 3D. So USD allows these layered scenes or layered objects, can be superimposed and seen as a one environment or one contiguous environment and scene as you render. That is what USD is able to do. Okay, details, I'll skip on this. As I said, there is many other protocols. USD is only one. MDL, Material Definition Language, is another one more standard. That there is, just as we speak, there are tens of standards that NVIDIA is adopting and complying. Same like the internet today, follows many protocols, many standards. So we are building together this metaverse following the standards. This is how the communication takes place between the data is being stored, pulled up to display, right? So those who are keen, go and take a look at it, at the detail. This is an example of more how the standardization is being maintained across different protocols. So if you know there is a HTML, there is a JPEG, MPEG, all these are standards, and communication protocol, TCP/IP, UDP, all these protocols, all right? So similarly, even in 3D world, there'll be more protocols, more standards to be complied. This is just an example. Okay, I'm coming towards the last part of my sharing, which is taking manufacturing as an example of industry and how they do product development, design, and all the way to do validation and verification using Omniverse as a platform. And I think I stressed in the early of the talk, while we are building metaverse, it doesn't happen overnight. Not one company, one person, one country can do it. It's everybody's doing. But you must build your own small digital twin or small web pages, quote unquote, right? Everybody must build their own. Then you can connect all this to become a larger metaverse. So like that, every company's, every entities, it could be campus, it could be, as I said, warehouse, it could be road, or it could be a river network. Everybody's building their own, the process taking place. I'm going to demonstrate one area which is in the space of manufacturing. So when we are building the digital twin for them, So you must understand who are the people in the manufacturing space. What are the challenges that they are facing today that they cannot solve in a physical world, so that they want to solve this in a digital twin environment, right? And then what are the platforms that you have? What are the features of the platform? So knowing the personas, the challenges, and then the platform key features, then you start to develop the digital twin, right? And of course, there is a lot of benefits of building, right? You can design this much faster. You can reuse the software and the code that you have built. It reduces the cost. You can even test and validate some features of the parts. In this case, I'm going to go through, pick an example, and then I'll run through, right? Okay, so as they do, the whole 3D workflow has multiple stages. Concept ideation, you ideate the concept. The next is you do a research and analysis in terms of the market. Let's say, for example, you want to design a bicycle, right? So you must have a concept of a bicycle, which so that when you don't want to infringe other people's idea, how you are designing a new bicycle or new tutut, right? For Thailand use, for example. But you want to make sure your idea is unique. Your product is something different. So then you do a research and analysis. Then after you do research and analysis, then you have the concept. It's all ready. From the concept and design, you want to translate into manufacturing and then distribute. Eventually, it's going to commercialization. So this is the whole cycle. So by understanding the cycle, we want to know what are the areas and opportunities where you can actually bring the design automation into it, all right? So like, for example, as we work with many companies, they could be building cars, right? The teams are located in a different part of the world. Like, you may have a company like Toyota, Honda, all of them is operating, or they have a manufacturing space in Thailand. But the designers may be in US or in Japan, or somewhere else, and working together with engineers in Thailand, right? So a collaborative, it is important. And then as they build the components of the car, it has to be full fidelity, right? As I said, it should be something real so that they can represent the real world, right? Then finally, they also want to validate, test it before it gets into product. So it can go into many components, right? So all that can be designed, validated as a workflow by multiple engineers working together. This is another example as we work with Volvo. So Volvo works with NVIDIA, where before they build the actual car, the whole car is actually designed, simulated, tested, validated, including putting into the production flow. Okay? So how the whole end-to-end pipeline, right? From the design, R&D, manufacturing, going to the end customer, all this is actually done through a whole end-to-end pipeline. Okay. As I shared with you, it could be even a small component parts of a bicycle. This is a bicycle chain, right? This whole bicycle chain can be visualized and understood before the whole bicycle is being designed. Okay? So this is how industry is actually adopting many of the components for creative design, architecture, engineering, construction, and so forth, building their own digital twins. And these digital twins, as they create collectively, put together, it becomes one verse. Right? And this verse is what eventually will become a metaverse connected for the world on many, many things. Okay, so that's a brief sharing that I have, how collaboratively people can work together, whatever industry you are in, whatever problem that you are trying to solve, right? We can create a digital twin. We can create a lot of simulations using Omniverse AI platform. Eventually, we will build the metaverse. Okay, with that, last two slides, this is where references are available for you to go and download, explore. There is a lot of good documentation, right? There is tutorials and webinars All these are free for you to go and join the tutorials, webinars, explore and read. If you have any questions, join the forum. And also, if you want to listen to people, other people who are presenting in a Discord, you can join the Discord session and also learn. Okay. Yeah, a lot of materials are available as part of the NVIDIA Developer Program for students like yourself for you to go and join for free. Okay. With that, I would like to end my sharing and open the session for questions.
Okay, all right. Thank you so much, Dr. Ettikan Karuppiah. So right now we are at the Q&A section. Please feel free to drop your questions below the chat box or comment box. So there are interesting questions from participants. The first one from Dr. Panarat. Okay. How can we start building the digital twin? Like, what kinds of tools can we use? And for example, if we want to see how the signal propagates wirelessly, how can we start building the virtual world?
Okay, it's a very good question, right?
Yes.
It's a very important question. And I think the question itself has given steps, right? So for example, a digital twin, you're trying to create a digital twin of, in this case, it could be a wireless propagation, right? So if you see wireless propagation, you need to understand the physics properties, physics material, right? So if you want to have the physics material and physics properties, so NVIDIA has a platform called Modulus. So Modulus is it's the SDK that NVIDIA has built, and this SDK will allow you to bring all the physics formulas. For example, in this case, wireless space, these wireless understanding can be brought together by implementing those features of the wireless, right? So that's it. It's a certain wavelength, and this wavelength has to be visualized. And then there is a physics properties for this wavelength, right? As it gets impacted or as it gets reflected and so forth. So the SDK is called Modulus. And Modulus can go all the way to every physics particles and physics properties of many of the packages. Is even some example of MATLAB functions can be brought in and incorporated. From there, the Modulus is actually incorporated into Omniverse platform, where the visualization could come in, right? So there are many other SDKs and platforms available. For wireless type of work, the propagation of wireless, to understand, Modulus SDK, and this Modulus SDK is actually as a component built in inside the Omniverse platform. Omniverse platform also has many other tools, including some of the visualization tool available for the physics properties. So that's where you can start with. So that's answering that question, right? I think the next question is, probably I'll just read the question straight, it's easier. Currently, we are seeing many well-garnered platforms in the area. Is there any recommended open standard movement, right? Similar to HTTP, HTML for the web, for building metaverse that the industry are focusing on? Okay, it's very good questions and very, very thoughtful questions, all right? So in industry, USD at least has been adopted, but of course USD is very much comes from the I would call visualization industry, right? But what we are seeing is there is actually a metaverse forum has been set up by companies, right? Currently, I think the metaverse forum is very much driven from United States. But I perceive over a period of time, we will see more forums will even regionally will take shape. Okay, but this is at least to start with, right? But it is not the whole list. This is a list of standards being adopted, right? For example, USD is only one, right? OpenVDB, then GLTF, right? FBX, GLB. This is all the file interface format that's coming up, right? And then for the extensions, this is the applications which is being adopted, which is already following some kind of standards. exchanging with the different type of applications. We are actually working with all these tools developers, platform developers, so that they adopt these common standards, so that all the tools and the component can be, can be interoperable. Same like HTML, HTTP, right? Those I would call standards designed and developed by W3C or IETF, right? Some could be, some of the protocols could have come from ITUT, right? So all this, so now the industry actually getting together. There already a formation of entities are putting together, right? But this is something that NVIDIA already working with industry partners, and I will see over a period of time is going to evolve. But it's still ever growing area for now. Okay, so that's the next question, right? Okay, regarding the Gartner prediction, Metaverse is still in the stage of technology trigger, and it will take 5 to 10 years to return on for ROI, return of investment, right? And also the technology itself is still up and down. I totally agree, right? So imagine in 1990, when we started to build the internet, a lot of investment gone in by the companies to build the internet, right? So the ROI was not there. But today, after 30 years, we build the internet, the ROI is impossible to be quantified. So the 5 to 10 years, I think it is, I agree, is a reasonable time as we build. But at least what we are seeing from NVIDIA's experience, every company is building their own verse, right? You call it as a universe, right? So verse. So each of these verse or each of this small bubble of internet or web pages, quote unquote, right? 3D web pages are already being built. So as they are building it, the industry see values because this actually increase operational efficiency. It decreases cost of operation. It increases productivity. So they are building, quote unquote, their own websites or their web pages, 3D web pages. So in the 5 to 10 years, when these 3D web pages or all these verses, right? Verse, I call it. Meta is many, right? Large verse, but they're already building these bubbles of verses. And in the 5 to 10 years, all these bubbles and verses will be ready to be connected or already connected between the companies or companies' partners, which we are already seeing happening today, right? So that means a cluster of internet will actually exist, a 3D internet within the 5 to 10 years. And after that, it's just explosion. Everybody will be part of it. But yeah, as I agree, it's up and down. It's a journey, but everybody is, many of the companies that we are working with is on the journey now. Okay. Yeah, I think that is the modulus component. Yes, you're right. This is the SDK that I mentioned. Thank you very much for sharing it. It's good for you to Google and search and put it in. Okay, so the next question is, how will it be successful and what factors the implementer needs to consider? So I assume this is in terms of the metaverse, all right? So I'll come back and draw to the point. If the companies are investing in building the metaverse, they have to, especially companies, they have to either make money or save money. This too is a core component. And today, as I shared with you, companies are investing heavily into this area because they can see operational efficiency, increase of productivity, save costs, and so forth. So those are the key indicator of success of such investment. Okay. So I would say many of these companies that we are working with, they are not totally new to digital twin. They actually already doing it before this, but it's just the scale of development could be small, or they have not partnered with the different companies to do a collaborative components. So now that is actually taking shape. Okay, the next question I can see is, I'm curious what will be the next step after that, right? Will there be a 4D internet? Very interesting. I don't know yet for now. We are still building 3D internet. I would like to contribute as much as possible towards the effort of building the 3D internet, so that I may live in 3D internet. I don't know what it's after metaverse. Right? Next question. Apart from the great workload of development, what do you think is the main technological challenge? Okay. Yeah, it's a very interesting point, right? Developing this 3D internet is, of course, is one of the I would call a major work that we need to do. Right? I will go back to 1990s, right? If you remember, with the creation of the internet, people talked about IT, information technology. People talked about doing digitalization, right? Setting up web pages, making sure every content to become a digital content, and building databases, building networks, and so forth, right? So that was a fundamental in 90s, where people collected data, put into database, have ODBC, JDBC, database type of protocols were put up, applications were developed, and so forth, so that we can have a simple automation process, right, to be done in the 90s and early 20s. So that is definitely, we have to put effort and put resources and put some investment to do development, right? So the question is, beside this, what will be the main technological challenge, right? So as what I observe for now, the collection of data is one challenge I see. So we need to automate a lot of data collection by using various sensors, right? And the data collection cannot be done by human, like what we used to do in internet, right? It has to be facilitated by RPA, right? For example, robotic process automation, right? So the collection itself has to be autonomous. It should be independent of human as much as possible, directly, not human intervention. Human cannot be collecting. So autonomous system has to collect the data, and the data, once it's collected, it has to be cleansed, it has to be integrated, it has to be easily to be put into a platform, which then can create the 3D world. So remember, I shared with you, as we build the 3D world, we need to build a lot of tools. So the next challenge is build the tools to automate the whole process. This is where a lot of invention, a lot of, I would call engineering work is already going in. So like, for example, I'm just giving an example. The paper which talked about the key technology of, this is I remember, I think it's IEEE paper or journal that been published, right? So one of it is the NLP, or language model evolution. And I'm sure all of you familiar with ChatGPT, right? Recently becomes very popular, right? So ChatGPT is nothing different than, it's a large language model. It's a language model, right? And ChatGPT today can give you close to 50%, close to, right? Some say about 40%, some 50% accurate answer. Of course, this is not acceptable, right? 50% is a bit low, but over a period of time is going to evolve. So how do you think ChatGPT able to collect the data? I didn't collect, you didn't collect, but you can ask some information about Bangkok or tourism in Thailand, and ChatGPT can give you a reasonably acceptable answer, right? Whether it's correct or not, I'm not sure. Right? Reasonably acceptable. So this is what I call is automating the whole capability of extracting the data, pre-processing, cleansing, and making it ready. Okay, so that's the technological challenge that we need to solve, right? From the 50% now by GPT-3, or T5 or DALI kind of protocol in language model to be much more higher grade, close to maybe 95%, 98%. That is what we need to do. But this is only one perspective, right? Language modeling, NLP, the same thing will apply for every different technology vertical that we need to look at, from image processing through to do a visualization of physically and also by physics correct information. I used to give an example. If you want to visualize a leaf dropping from the tree, right? As you build the 3D environment, how can you build the tool so that the tool incorporate gravity, the tool incorporate the weight of the leaf, the tool can incorporate the wind strength, wind direction, so that the leaf doesn't drop directly, but the leaf does not drop directly, but the leaf can actually float. And while floating towards down, depends on the direction of the wind, the leaf may go up, but come down again and float and drift. How can you bring this reality? You got to build a lot of tools for this, right? Automate the whole process. Next, can you give the recommendation how to prepare to stay on trend with Metaverse and Omniverse? How university students can prepare for this revolution, right? First of all, I think AIEI already doing a great job having this session to be organized, right? As the first step, which is basically getting to know what exactly is happening, right? So reading, understanding what's happening is very important. Next is, I would say, today, as we speak, NVIDIA is actually building a content, one semester subject for Metaverse, right? It will be, currently we are actually, we are testing with a few universities in the world. I think by another 3 to 6 months, this syllabus will be available. It's same like you have the teaching kit for AI, teaching kit for robotics, teaching kit for data science, right? There will be a teaching kit for Omniverse or Metaverse. We are working on this. It will be made available to you. So my suggestion for the university, of course, it sounds little, sound little crazy, but nothing crazy than thinking differently, right? You may have a subject called Metaverse for engineers, right? Whatever name you can give that, right? So you can put together some content, right? And how can the content could be orchestrated, put it into a syllabus and deliver to the students, right? So that's one could be for the university to look at. NVIDIA is already building a 6 months or 1 semester subject and syllabus by working with a lot of leading universities in the world. Will be available to you. Then you can take a look at it, how you can get it implemented at your university. So there's a full syllabus. With the syllabus, of course, there is a hands-on lab, some experimental softwares, algorithms, or tools are available that you can actually look at it. Okay, so this is from the syllabus perspective. But a student perspective, I would say, look at some of the leading companies which are actually working on this Metaverse. Follow, read the papers, read the blogs, go through the videos. Of course, you can watch many YouTubes, but if you can watch YouTube related to technology, will be good. Yeah, that's and also do some projects, right? Hands-on projects. So work with your professors and your lecturers there for your final year project or for your second year project or third year project. Put some small projects using Omniverse. You can actually learn. Okay. Is it going to be a huge disruption? I mean, it can be as bad as COVID-19 disruption that we had, right? I would say it is a gradual transition. from our today's internet to the next. And in fact, some of you were already using or familiar with AR, VR, XR. You're already into the space, right? Into a mixed reality or virtual reality, whichever area. Right? I would say this is going to be incremental technology evolution that will take place. It needs a reskill, definitely required. It needs the whole industry to adapt and adjust. So engineers has to be trained differently. Engineers have design capability, coding capability, and also able to translate a workflow easily. But I think I would say for STEM education, people who are in the STEM cycle could easily adapt and adopt the technology. It won't be too disruptive for them. But of course, for some people who may not be familiar with the whole technology, might see it as a disruption for them. Okay, when will CMKL, NVIDIA, Tech Talk move in the metaverse, Omniverse? Very interesting, exciting question. Yeah, definitely we can do, right? I actually presented last year in, it's not really a metaverse, but it's more on XR type of environment. I was using a head mount device, Oculus in this case. And then I was presenting to a group of, I think, 200 people virtually in the stage and sharing, and we had a discussion. So I'm sure CMKL can create CMKL-verse, right? So metaverse, right? So CMKL-verse, digital campus of CMKL, and then I can digitally meet you in your digital lecture theater, and all of you seated in a digital lecture theater, and I can present and share with you. So a time to put up a project and work on that project.
Okay. All right. If there aren't any questions, I'd like to thank you, Dr. Ettikan, for today's talk, and we hope you come back as our speaker again next time. We really sincerely appreciate it. Okay.
Thank you very much.
Yes,
for
thank you so much.
Giving this opportunity to me. And
yes, you're welcome. Okay. Before we leave, I'd like to inform you that we will have the next talk episode on this Friday, January the 20th, about building an AI startup by Assistant Professor Dr. Ettikan Wong, founder and CEO of EatLab. If you are interested in attending, please register at our poster. Okay, and see you there. So that's it for today's talk. Thank you, Dr. Ettikan again, and also thank you everyone for attending our first TikTok 2023, AIEI x NVIDIA. We hope to see you again in the next episode. Please stay tuned. Have a nice day. Goodbye. สวัสดีครับ